When we look up at the night sky, space appears completely serene. But cross the threshold into our actual solar neighborhood, and you enter a lethal gauntlet of roaring fire, crushing pressure, and freezing tempests. This diagram outlines the exact baseline criteria human biology requires to survive on a planet. We need a stable temperature range, a thick, breathable atmosphere to regulate that heat, and a solid, pressurized surface to stand on. Out of the 8 major planets orbiting our Sun, 7 completely fail to meet these basic metrics. In fact, they are actively hostile to the presence of life. As we move outward from the Sun, we can use these survival metrics to test each world we encounter. By checking each planet against the physical requirements for life, we can see exactly where the boundaries of the solar system's habitable zones truly lie. This map shows the terrestrial, rocky worlds closest to the Sun, starting with Mercury. Orbiting just 36 million miles from the solar surface, it is a heavily cratered rock barely larger than our own moon. Because Mercury completely lacks an atmosphere to regulate its climate, its surface temperatures swing violently. In the direct sunlight, it reaches a blistering 800 degrees Fahrenheit, but the moment night falls, that heat instantly bleeds out into space, dropping the surface to negative 290 degrees. Pushing slightly further out, we reach Venus. At 67 million miles from the Sun, you would expect it to be cooler. Paradoxically, Venus is actually the hottest planet in the entire solar system. This cross-section illustrates the mechanics of a runaway greenhouse effect. Venus is wrapped in a massive, dense atmosphere of carbon dioxide and thick clouds of sulphuric acid. Solar radiation enters, but it is unable to bounce back out into space. The trapped heat pushes the surface temperature to a constant 900 degrees. Scientists believe Venus may have once harbored liquid oceans. Today, its hellish surface serves as a direct warning of what happens when a planet's climate regulation completely collapses. The third rock from the Sun sits safely at 92.9 million miles away. This exact distance keeps water liquid and allows Earth to hold on to the dense atmosphere required for a thriving, diverse ecosystem. This photograph shows the landscape of Furnace Creek in California's Death Valley. It was here in July of 1913 that Earth recorded its highest atmospheric heat, 134.1 degrees Fahrenheit. In this image, we see researchers dealing with the exact opposite baseline. At a Soviet weather station in Antarctica in 1983, the temperature plunged to negative 128 degrees Fahrenheit. Looking at this panoramic view of Mars, you can immediately see the consequence of moving past Earth's safe zone. Roughly half the size of our home, Mars is a dusty, frozen desert. Because Mars has significantly less mass, its gravity is 62% weaker. A person who weighs 220 pounds on Earth would step onto the Martian soil and weigh an astonishing 83 pounds. But stepping onto that soil comes with freezing consequences. The average temperature across the Martian desert sits at negative 80 degrees Fahrenheit. Without a thick atmospheric shield to trap heat and deflect radiation, a terrestrial planet becomes a dead rock. Earth thrives, while its nearest neighbor sits entirely unprotected. Crossing into the outer solar system, solid surfaces disappear. This diagram shows Jupiter, 11 times larger than Earth. Venturing past its freezing upper clouds, extreme pressure compresses hydrogen gas into an ocean of liquid metal, creating a core temperature of 43,000 degrees Fahrenheit. This image reveals the raw violence of Jupiter's weather. The Great Red Spot is a continuous hurricane-like storm packing 270-mile-per-hour winds. The storm itself is twice the size of our entire planet. Moving out to 886 million miles from the Sun, we reach Saturn. Here, conditions change violently depending on depth. The upper clouds of ammonia ice hover at negative 280 degrees Fahrenheit, eventually giving way to frozen water, and finally ending in hot, heavy lower layers. Here we see Saturn's iconic rings. The sheer visual beauty of the orbital ice and rock creates a breathtaking distraction from the deadly, unlivable gaseous steppes below them. Past Saturn lie the ice giants. Any attempt to land a spacecraft on Uranus would simply end with the craft sinking. The planet holds its mass in a hot, dense fluid mixture of water, methane, and ammonia. That heavy atmosphere is mostly hydrogen and helium, but it carries trace amounts of methane. That specific chemical addition absorbs red light, giving Uranus its distinctive blue appearance. Finally, almost 3 billion miles away sits Neptune. It is a near twin to Uranus, but holds the title for the coldest planet in the solar system, with atmospheric temperatures plunging to -360 degrees Fahrenheit. Across its dark surface, immense dark vortex storms routinely grow to the size of Earth. The outer solar system abandons the idea of solid ground entirely. It is a massive domain defined entirely by crushing pressure, toxic fluids, and violent winds. Retracing our path backward, the scale of hostility becomes clear. We pass through freezing oceans of metallic fluid, past gas giants wrapped in eternal storms, and over inner worlds baked by runaway radiation. Suspended in the middle of these massive extremes sits Earth, a perfectly balanced oasis drifting through a highly lethal void. The stark conditions of Venus and Mars prove exactly what happens when that balance falters. The loss of an atmospheric shield, or the buildup of trapped heat, turns a planet into a permanent wasteland. This survey of our planetary neighbors demonstrates that life requires a very specific physical balance. While we often look toward colonization as a future escape, the data suggests that Earth is currently the only environment in the solar system capable of sustaining us without the constant threat of total collapse.